Hello and welcome back to another school year. Welcome to Flipped Classroom. We all know that you love it so much. But really though, I love doing this method because again, we take out all of the extreme note taking in class and we kind of slow it down and discuss it a little more. So these are just brief things that you should remember from last year. If you don't, no worries. It's been a long summer. I am changing a few things when it comes to taking notes in the class. So hopefully that will be a little bit easier when you're actually watching the video. You guys gave me feedback last year and hopefully I can meet some of those needs. If you still have huge issues, please make sure you are talking to me. If you have an Edpuzzle problem, anything like that, you need to talk to me as soon as possible. You can't just put it off and then say, oh, I couldn't do my homework assignment because A, B, and C. But again, just a brief reminder, this is your first video. All of your readings will always be linked with the video on Canvas, so you can look at and go back and reference something. I am taking chemistry in a different direction this year, so it's not going to be the same as last year. There are things that I didn't feel were necessary for last year's class, and so this year I'm going to try and make sure it's a little bit different. We'll spend a little bit more time in the lab. So a lot of the readings may not actually, all of the information from the reading may not actually be something that we learn about. So bear that in mind when you're looking at the readings. I will try and go through the reading if you have any questions on it and tell you that we're not doing this portion, but we're doing this portion. With that being said, let's just go ahead and start talking about the study of chemistry, or what is chemistry. All right, again, remember, I do have an objective slide. I used this particular PowerPoint from last year, so some of the objectives may actually not reflect on what's in the PowerPoint. And I apologize for that. That's just me forgetting to edit the objectives, and that's really just my fault. So again, I want you to define chemistry, relate chemistry to what you may already know, list the steps of the scientific method, and understand concerns with chemistry in the modern world. So how we actually see chemistry in the world. It's really important because chemistry can be a really dull subject if you let it be. But the fact of the matter is that chemistry is going on all around you. So it's really impressive that something so boring has such a vital role in our everyday lives. And yes, I know I talk fast. I am going to try and slow down. That was my huge problem last year, and I'm catching myself, so I'm trying to talk slower. All right, so how is chemistry defined? Now, the first thing I'm going to tell you is at the end of last year in biology, I started writing my notes in my notebook and then writing them on the board to slow things down. I am going to continue to do that. So what I'm going to do for you is I am going to upload my own notes to Canvas with the video as well. So that way you're not rewriting your notes if I add something or I change things. Your notes are not out of order. I know that was a huge issue last year. A lot of people didn't like to write their notes out of order, and then they left too much space, and it just really bugged them visually. And that's something that would bug me as well. So my recommendation for note taking is to not actually take the notes during the video. And I'm going to talk about this in class. So please don't freak out if you're like, what is she talking about? I am going to talk about this and what I expect you to have done when you come into class and what you should be doing while we're actually having these discussions. So while I don't want you frantically writing all these notes in class, I do want you to kind of have a little bit more of an understanding just by listening to the video. So again, I'm going to give you several options in class. Do not freak out if you don't have much room. If you are somebody that just wants all your notes in a particular order or the same order that I have them in, write your notes at the end. When you look at all of my notes from my notebook, that's not bad and that's not wrong. Take your time, listen to the video. All right, so chemistry is the study of matter and the changes that matter undergoes. And if you remember anything about matter from like 5th grade, matter is anything that has mass and takes up space. So basically every single thing. There are particular things that are not necessarily considered matter. Things like sound, light. So those aren't considered matter, but anything around us that has mass and takes up space is considered matter. So that includes non-living things, so like rocks, dirt, things like that. Well, dirt's kind of living, but you get my gist. Chemistry affects nearly everything we see and every action we take. So everything you do, chemistry. Yes, biology is the study of life, but that doesn't explain the actions of the rock that something went going on with a rock, and that's a non-living object. So now we're going to take the idea of living and non-living and relate those two things in chemistry. I would recommend that you know the definition of matter, and it has mass and occupies space. That's not something that I think is something we will review in class, because I think that's just a very straightforward thing. Now, some of these instances that I'm going to talk about right now, do any of these things sound familiar to you? Flame in a gas stove, bubbles in Alka-Seltzer, rust, bread rising. All of these instances take chemical processes to happen. Some of them are much cooler to watch. Some of them take years and years to happen. But the fact of the matter is that these are all examples of chemistry. Changes in matter. Changes overgone over a period of time due to the interaction of different elements. And we're going to talk about what elements are. At some point in the school year, you'll probably be able to memorize a part of the periodic table. But for right now, don't worry about that. These are certain instances. So again, I told you not to write all of these notes frantically in your notebook, because look at how many words I've used. I haven't even used a lot of words. So you know I'm going to add notes in my own notebook. That notebook is always available to you. Don't feel like you have to frantically write the notes right now. We are going to be focusing on particular different types of chemistry and how they are seen in our actual world. There's what's known as pure chemistry and applied chemistry, and I'm going to add these into this set of notes, so don't worry. Pure chemistry is what a greater understanding of chemistry. So just really we want to understand theories and how matter changes, and that's really how we are going to look at it in this class. But the more interesting stuff is actually when we talk about applied chemistry. Applied chemistry is when you have a direct goal, and a lot of the times that's where the money's at. So if you can apply a scientific principle to the growing of nylon, and boom, you have a product and you can sell that product. That's still chemistry, but now you have an intended target. Pure chemistry is really ideally what we like to do in the classroom, but in the lab, we're going to apply that. So we're going to see both of these. And in our real world, we see these pure and applied chemistry or chemistry concepts when we're talking about energy. We talk about medicine, materials that we use every day, the environment, agriculture, very agricultural area that we live in. And it's so it's really nice to see how we can apply the study of chemistry to agriculture and even to medicine, right? We want to keep advancing in medicine to make sure that there's help for everybody out there. And if we keep using applied and pure logic, we can get there and we can help more people. In this video, I am combining two sets of reading material only because I feel like it was such a waste of time last year to break this up into two videos. You guys have had me for a year already. You kind of already know my expectation. Not that I'm going to try and breeze past this, but we kind of already know how to do this stuff. And so I don't want to waste your time this year. Last year, again, I feel like I wasted time making too many videos when I could really combine them and use that time to do something else in class. So with that being said, this is the second set of reading that I'm going to provide to you. Again, I've skipped so much in the first set of reading. Like, we're not going to talk about the different types of chemistry. I can explain that very easily to you. It's not something that you're super concerned about, so I'm not going to waste your time. Scientific method is something that we always use, and it's a series of steps in scientific investigation that is followed. Now, one thing I want to make sure that you understand is, yes, it's a series of steps, and it's a great visual to look at, but the scientific method isn't actually always done in a particular order, because what happens is during scientific investigations, you make an observation, and yes, you ask a question, but that asking that one question may form into 3 different hypotheses that you want to test. And then those 3 different hypotheses may form into a new question. So you can go backwards and forwards on the scientific method. It's not completely just one direction. It is more of like a process. It's a great way to move through things, but it's not concrete. You can go out of order. You can go from forming a hypothesis to communicating your results, because you simply did something and it wasn't this crazy experiment. Or you can test that hypothesis, and instead of drawing conclusions, you communicate those results because you really don't know how to draw the conclusions from what you got. Or let's say you tested nothing worked out, and you go right back to the drawing board. So again, it's not a super concrete method. It is very, very flowy, very easily to turn back or go forward, skip steps, not concrete. Now, when you're doing scientific investigations, the big things that happen are that you make an observation. So that's always the first thing, and that's always going to lead to a question. Typically, if you're making an observation, you're asking a question at the same time. So I may ask myself, why is Jackson crying? And I probably used this example last year. And I'm going to give you a better example in class, so don't freak out. And I didn't even have to establish that I made an observation. I just simply asked the question. I have observed that Jackson's crying, so now I'm just automatically going to asking a question. So scientific method, it can start with just asking a question rather than just making the observation. Those two things can go very much hand in hand. As we lead into asking a question, we form a hypothesis. So we form an explanation, a testable explanation for something. Jackson is crying because Jace stole his toy. Go figure, right? Jace is kind of mean right now. We're going through a stage. But anyway, so we ask a question, we form a hypothesis. Jace took Jackson's toy. Now, that's a testable explanation. If I were to take that toy from Jace and give it back to Jackson, there are two things that could happen. Jackson could keep crying or Jackson could stop crying. That's where I test that hypothesis. So now I'm taking the toy from Jace. Jace is now freaking out, but Jackson's not crying anymore. I draw conclusions. Jackson wanted the toy. Jace took it from him. I communicate my results by putting Jace in the corner, taking the toy from Jackson, so nobody's happy. That was my summer. There, you figured out what happened during my summer. But anyway, seriously though, this is a great way to figure out an answer to something or get there. Now, let's talk about testing the hypotheses. There's a number of ways you can test your hypotheses, but the greatest way to do that is by an experimental investigation. So testing answers, and typically this is done by an experiment. And you want to do a lot of experiments in the lab because if you don't, then there are a lot of factors that could mess with your findings. So typically these things are done in the lab to control as much as possible. Now, when we talk about experiments, there are some things that we need to talk about, and these are known as variables. You should remember this from last year, but if you don't, again, it's been a long summer, no worries. Variables, there's two types, a dependent variable and an independent variable. And if you read that, dependent means it depends on something. Independent, it's on its own. So a dependent variable in an experiment is the variable that is affected by another, so affected by the independent. An independent variable is the variable that affects the dependent variable. So a good example would be distance versus time. Time is always the independent value. Distance, so whatever distance I travel is a variant of time. It depends on how much time is passed. And I'm going to give you that example in class, so don't chip if you just don't remember or know what I'm talking about. I'm going to show you what these look like. We will probably quiz over the scientific method, but again, don't worry, I'm going to give you everything you need to be successful. All right, I'm pretty sure that this is a very, very short video, but my notes are probably not going to be short. I haven't written them yet, but you know me. All right, welcome back to school, guys. See you later.